हेलो स्टूडेंट्स, हाउ आर यू? कैसी तैयारी चल रही है? वेलकम टू माय चैनल. इफ यू हैव नॉट सब्सक्राइब माय चैनल yet, then please subscribe by pressing the subscribe button. You can also suggest your friends to subscribe my channel. In the last term, we were discussing about point defects. Point defects are of three types: stoichiometric defect, impurity defect, and non-stoichiometric defect. In case of stoichiometric defect and impurity defects, the stoichiometry of the crystal is maintained. But in case of non-stoichiometric defect, the stoichiometry of the crystal is disturbed. It is not maintained. Many inorganic solids are known in which the stoichiometry of the crystal is not maintained. The non-stoichiometric defect can be further classified into two types: metal excess defect and metal deficiency defect. First, we shall discuss about metal excess defect. In case of metal excess defect, it can be due to metal excess can be due to presence of anionic vacancies. Metal excess due to anionic vacancies. Anionic vacancies. These type of defects are generally found in alkali halides. For example, sodium chloride, potassium chloride, lithium chloride shows this type of defect. For example, when sodium chloride is heated in the in the presence of vapors of sodium, then the sodium chloride turns yellow. This type of defect is present, metal excess defect, and it turns into yellow color. Sodium chloride is generally white, but due to the presence of metal excess defect, it turns yellow. When it is heated, when sodium chloride is heated in the presence of sodium vapors, then it turns yellow. Now, I shall discuss the phenomena why it turns yellow when it is heated in the presence of sodium vapor. First, let us consider the crystal structure of sodium chloride. This is the crystal structure of sodium chloride, in which sodium ions and chloride ions are arranged in a regular arrangement. Now, when sodium chloride crystal is heated in the presence of sodium vapor, the sodium atoms get deposited at the surface of sodium crystal. Now, the chloride ion present inside the crystal diffuses. Diffusion process takes place. The diffusion of chloride ion present in the crystal lattice takes place to the surface, and it combines with sodium ion to produce sodium chloride, and there is one vacancy inside the crystal. There is one vacancy inside the crystal. In this process, the sodium atom deposited at the surface of sodium chloride crystal gets ionized, and the electron generated during this process gets diffused inside the crystal lattice and occupies the position of chloride ion. The electron diffuses inside the crystal lattice and occupies the position of chloride ion. This This center is called F center. This center is called F center or color center. It is known as color center. Since this center is responsible for the color of sodium chloride, therefore it is known as color center. F is a short form of German word for magenta, which means colored. Now, when visible light, why this sodium chloride changes into yellow color? This is due to the reason when visible light falls on this crystal, the electron gets excited. The electron present inside the crystal gets excited, and due to this excitation it goes into higher energy level. When it comes back to lower energy level, it produces yellow color. Therefore, the color is due to the presence of these electrons, and these electrons are known as F center or color center. Similarly, if lithium chloride crystal is heated in the presence of vapors of lithium, then it shows pink color. Another example of metal excess defect is lithium chloride. When it is heated in the presence of lithium vapor, it turns pink color. It gives pink color. Thus, in case of metal excess defect, the metal excess defect is due to the presence of anionic vacancies. The chlorides present inside the sodium chloride crystal gets diffused to the surface and combines with sodium atom to form sodium chloride, and the electron generated during this process gets diffuses inside the crystal and occupies the position of chloride ion. And when visible light falls on this electron, since there are many electrons, when this visible light falls on this electron, it shows yellow color. This is about metal excess defect due to anionic vacancies. Similarly, the metal excess defect can also be due to the interstitial position of metal ions and electrons. Metal excess defect. Metal excess defect due to interstitial position of metal ion and electron. For example, zinc oxide is generally white in color. When it is heated, it produces zinc ion and oxygen molecules are removed and two electrons are produced. Now the oxygen site inside the crystal is vacant. Zinc ions occupies the interstitial position and electron occupies the interstitial position inside the crystal lattice, and the zinc oxide crystal shows yellow color. It converts into yellow color from white. This is the metal due to metal excess defect. Now the last is metal deficiency defect. What is metal deficiency defect? Let us consider non-stoichiometric defect. Second is metal deficiency defect. The metal deficiency defect, there are many solids in which the metal is present in lesser amount. When these compounds are synthesized, the stoichiometry of the compound shows that metal is in lesser amount. For example, when iron oxide is produced, it has been found that iron is not present in stoichiometric ratio 1:1. Iron is present in lesser amount, its stoichiometry is 0.95. It varies from, the composition of iron varies from 0.93 to 0.96. This is known as metal deficiency defect. Since in these solids metal is originally present in the synthesis of these solids, metal is present in lesser deficient amount, so it is known as metal deficiency defect. So today we have discussed about non-stoichiometric defect. In this defect, the stoichiometry of the solid is not maintained, the constituent particles are not present in the stoichiometric ratio, as is the case in stoichiometric defect or impurity defect. These defects can be two types: metal excess defect and metal deficiency defect. Metal excess defect can be due to anionic vacancies. For example, in case of sodium chloride, when it is heated in the presence of sodium vapor, it imparts yellow color due to the presence of anionic vacancies. Due to the presence of anionic vacancies, metal becomes excess. Similarly, metal excess defect can be due to the removal of oxygen. For example, in case of zinc oxide, when it is heated, oxygen is liberated in the form of oxygen gas and metal becomes excess and occupies the interstitial position, so it changes its color. Similarly, metal deficiency defect, originally a solid can have metal in lesser amount. For example, in iron oxide, iron is present in deficiency amount. So today we have discussed about non-stoichiometric defect. Please like, share and subscribe my channel. Your comments are welcome. Thank you once again.